Hello everyone, this is Mahmoud Ragih and today I'm going to talk to you about two types of analysis that we use in our structure design. The first type is conventional analysis and the second type is construction sequence analysis. And we will talk about the differences between them and how can we use each of them. First, in the conventional analysis, ETABS deals with the whole structure as one unit. And in the construction sequence, no. In construction sequence, the etaps knows that we will build the first story, and after that we will build the second story, third story, fourth story, and so on. In the construction sequence, we need it not only in planted columns on the transfer beam, but also for other cases. For example, if we have outrigger and this outrigger will be constructed after finishing the main skeleton of the structure, or if we have a pour strip when we are working in a podiums and a tower. For example, if we have a tower like that, we have here the full tower and we have pour strip in this area, and we want to tell ETABS that the tower will be built and the podiums, and after that we will pour the pour strip after finishing the tower construction. We make this to avoid adding more stresses on the corner cores or corner shear walls, to avoid increasing their sizes. So, in general, construction sequence can be used not only for plantation but also for the towers if we need more realistic results. Okay, but in conventional analysis is acceptable in very small buildings or medium buildings, for example, G plus 10 or G plus 12 building. Okay, how can we find the difference in analysis results between the conventional and the construction sequence analysis? I made a construction sequence case contains own weight and 50% of the superimposed dead load, and another case linear add, it's for own weight and also for the 50% of superimposed dead load. This video I will not talk about the creep and shrinkage and material of the structure. We will talk only about the construction sequence case and the difference between it and conventional. In other videos, we can talk about the creep and shrinkage, how can we insert this data inside the construction sequence and how it will affect the structure design, especially for the column shortening when we check it. Okay, so here what I made is, when we go to define load cases, I have here a sequence case. This sequence is non-linear and the building contains 30 floors, so we have here 30 stages. We don't put duration because we will not take creep and shrinkage in this analysis video, and we avoided taking material properties time dependent because also we didn't take creep and shrinkage. Okay, so that's just telling the program that we will put the first story after the second story, third story, fourth story, and so on. Okay, and add another case, it's dead load plus 50% of superimposed dead load. If we go to it, it's linear add and it contains self own weight or own weight of the structure and superstructure, 50% of superstructure. If we go to this construction sequence, it contains also the same concept. 100% of own weight and 50% of the superstructure. So let's run the program and check the displacement or the vertical displacement of the middle column here and how it differs between conventional analysis and construction sequence. Now it's okay, run is finished. We will select the joints of the column at all stories. So from here, check all stories, select the joint, and from display, show tables, go to joint output, displacement, joint displacement, select the case which is sequence, then okay. We will select the step, the minimum Okay, and file, export current table to Excel. Here we need only Z values and the story. And the story is 30. We will make it as numbers 29 and so on. We can make the numbers as positive values by multiplying it by -1. And after that, we will copy it and paste here as a number. Now we don't need this column, we will delete it, and we will make a chart to display the displacement regarding the sequence. From insert chart cutter, from select data, add this series is sequence, and the x direction of the chart is z values displacement, and y in the chart is the story number. Then press OK. This is a displacement of the center column regarding the construction sequence. This means displacement increases till the middle of the stories, and after that it decreases again. But when we select the case of conventional analysis, we will find another behavior of the building. So if we select the case of own weight plus 50% of superimposed dead load, display shoot tables, select the case, this one, okay, and here this is the used values, Control C, we'll go to the Excel, Control V, we'll multiply it by -1, and then Control C and paste here as a number. Now we don't need these columns. If we press here to add or to insert data or select data, add, this series is conventional, and x values is z displacement. No, we didn't place them in a right way. Just select them, put them here, and again select data, add, this is conventional, x direction is these numbers, and y direction is the story. This is the story. Then press OK. Here we can find the difference is very clear. As in conventional analysis, it's assumed that all the column will have a displacement, vertical displacement, and the same values to down. But the correct answer is not the conventional analysis, the construction sequence analysis, because we have the formula that delta, the displacement, equal P, the load, multiplied by L, the length, over E and E multiplied by A, Young's modulus or modulus of elasticity multiplied by the area. When we check this formula, we will find that we will have the maximum value of displacement in the middle of the middle height of the tower, and small values in the top and in the bottom. We can explain this more in another videos, and we can add the creep and shrinkage and check the difference between the construction sequence before creep and shrinkage and construction sequence with creep and shrinkage.